Definitely. There we go.
Cool.
All right. Cool.
Hello, guys. Thank you for coming out. I know it's pretty busy with midterms and all that, but thank you. Today we will be presenting firewalls, web defense, and containerization with myself, Suchit.
Michael.
Krishnan.
All right. Yeah, I was just saying this a minute ago, so let's breeze through it real quickly. I really need to know ASAP how many of you would be interested in being on the second roster. So by show of hands, I got one people. All right, you got a DM me on Discord. Is that information? It's comfortable, but that's what we need to do to put you in a now. Now, this only happens if we're approved for the second team. So I just need to know tonight because I really want to sort that out with Amanda Teal tomorrow. Amanda is the one who runs the program at SIGPwny. All right, that's all. Yeah.
All right. So something about me. My name is Suchit. I'm a helper. I'm in CS, MCS, and I did mock trial in high school.
Bro, what? Okay. Well, there's so
Weird. Refresh.
Anyway, you guys know what it looks like, right?
Refresh. Yeah. Let me.
There we go.
There we go.
Okay. Well, it's good. So there's supposed to be a photo of me there, but there it is. I'm Krishnan. I'm a SIGPwny helper. I'm a computer engineer in class of 28. And I couldn't think of fun facts, so I picked the most niche thing I do, which is plane spotting.
That's sick.
Right. And this is the flag, the meeting flag. I'll leave it on at the end. It'll also be posted after. So yeah. So what is a firewall? Firewalls monitor incoming and outgoing network traffic, and basically it's a way to look for suspicious activity and to block it. So there are different types of firewalls. There are stateless firewalls, stateful inspection firewalls, proxy firewalls, and next-gen firewalls. Proxy firewalls operate on layer 7, which is, I guess, like the highest layer. And then next-gen firewalls operate on layer 3 as well as 7 with heuristic analysis. So next-gen firewalls are considered the most like advanced firewalls as they can monitor most layers of your OSI stack. And they're basically used to determine like, okay, let's say use Nmap or something like that. We're all familiar with Nmap from last time.
Yes.
So let's say that, a network analysis analyzer looks at it and just like, okay, this one source keeps pinging us over like 1,000 different times. This must be an Nmap. So then you block their source IP, and then they can't Nmap you from that source anymore.
Sorry.
But
Turn on your camera.
no, turn on. I bet. Let me try that.
Bring the panels back.
Oh shit.
I'm asleep. That's perfect. Questions.
I know why it's fine. Yeah, just keep going through the slides. Don't even worry about it.
Okay. For a reference, the background is like a shot of the Earth from space. It's pretty cool. The reason I put that background was I would go to online classes sometimes and I'd just sleep on my bed. So I put it so that they couldn't see the pillow behind my head. Basically, that was the analysis. God damn, bro. What? Okay, there we go. Do you want to take this one, Michael, or do I got it?
Yeah, okay. I mean, so when you ask the question, like,
Michael.
what is a
You might want to talk
Oh, there.
about it. Yeah, because the
Yeah.
recording and stuff.
Hey, sorry. Hopefully this is better. When you're asking the question, like, how does a blue teamer actually defend, right, against malicious traffic in a live setting? This is your answer such that it is live detection. Do you get that? So that is the way that you achieve this. I've told you guys like last week that they're like locks on doors. So hopefully you have a segmented network with maybe a demilitarized zone, right? As you may know, it's a DMZ. Doors need locks. So you break into somebody's house and you want to walk through the different rooms of the house, but you get stunted in the process because you need to get through the locks, right? That's what firewalls do. They're both GUI and command line accessible. And what they're supposed to be doing is inspecting packets, either the headers, or you can set them to inspect full packets. And we'll talk about some concerns about that later. Before forwarding them to a client system on a LAN server, right? So basically from WAN, your wide area network, what's public facing and available outside of your private network, your 192s, your 172s, and your 10s, right? So that is essentially what it will do. Now, how does it work? If implemented correctly, it prioritizes rules, and we're going to visualize this in a minute, at the top for the traffic types that you will have more frequently over a network. So for example, if you have a dedicated box that is more specific to web traffic, right? The obvious ports are 80 and 443. You can set rules specifically to either whitelist or blacklist, depending on what you prefer. And the way that it works in a firewall is that it reads and processes the rules in hierarchical order. Priority is top to bottom. So whatever rules, despite the two that they automatically populate you with on some firewalls like pfSense, the ones that you actually create for yourself are going to be prioritized and read sooner. That's the most important thing to remember, at least in terms of what you're going to set this up for. Implicitly, firewalls are known to do what's called deny any. So if you don't write some rules, there are some firewall services out there that actually implicitly just deny traffic. You should specify what you'll allow through and what you won't allow through. The rules are written directly into the interface. So whether this is a command line through a daemon or a service like that, sorry, not a service, background process, or an actual GUI like pfSense. And we didn't talk about Palo Alto today, but that is another popular option. And at some point, we'll have to revisit that. And firewalls can have multiple interfaces on them. So just like a router would. Your firewall is essentially going to sit right in the middle of what's probably out there. Like, say you have an attack box, and you want to communicate or try to communicate with a box that's inside of the network. It's going to go through the firewall first. If it passes, the traffic is actually okay and acceptable, then it'll let whatever's on the LAN side communicate to the LAN side. Does that make sense? So it's got to pass through the firewall to inspect it first. Most of the time, a lot of people like to configure it such that a firewall forwards the packet to a gateway, your router, right? And then over to you. So that's the thing that supplies the internet and actually allows you to actively use it and determines whether to drop you if it doesn't like the traffic that you're producing from your machine to that machine. Tough concept to understand at first. We'll try to visualize it a little bit later.
So here are some of the basics of like a firewall rule. You want to specify your source destination address, obviously. You want to block from like whoever's incoming was. Let's say you're end mapping from a specific source address. You want to specify that source address to block. Your destination address, whether it be, the server that you're hosting and you want to block traffic from source to the host. The reason that you want to specify both is, let's say you have a specific source IP that you want accessing one service, but you don't want accessing the other. So this allows you that modularity where you can block a certain connection, but you would allow different types of connections. So let's say maybe somebody has privileges to one server, but not the other. That would be the case for you to specify source and destination. Now you would specify the ports this is on. It can be like any or very specific ports. The protocol meaning like TCP, UDP, and the action meaning deny or allow, and then basically the direction. So we know inbound and outbound, right? So outbound is when you're sending messages to somebody outside of your network. Inbound is when somebody's sending messages inside to your network. Basic source. And this helps monitoring and filtering ingress and egress traffic. So you would say your action would allow source, IP, destination to any, and then using the protocol TCP with ports outbound traffic. So this is basically allowing you to send traffic from this IP to any device through TCP. Yes, oh, and it's just specifying that it can be any of these addresses. So 0 to 24.
So 192.168 is a very popular private network based off of the RFC 1918 specification. What's the keyword I'm looking for? RFC 1918 calls into It's a standard, okay? That standard basically says if you have private network, use private IP address as an often follow 192.168 or 10.10 dot something like that, right? If you look in your actual computer, there's a chance that you might have an IP address right now assigned from Illinois Net on this Aruba router that's been assigned to you as a 192.168. The subnet /24, part of the networking infrastructure, is that if you fall within the 192.168 boundary on up to, I think it's 255.
So it's gonna be, 256 IPs for a /24 network. So basically, it's the last digit.
It's the last digit. If your digit falls within that subnet, you are on that local area private network. So then that's what's allowed. If you're outside of that address, if you're not in 192 or you're outside in another sort of way, then you can't actually. The firewall, as it's saying right now, is going to block you from even accessing the internet on the network. Basically, right now.
What questions?
We have questions, yeah.
Yeah, so networks, are they always in a port or can they be like any number?
They can be any number. So you can have, for example, /32, and that's one IP. So that's like everything is part of it, like everything is not part of your network. So only if you're 192.168.10, you apply the rule. And for example, you can also have let's say like 15 or something, and that would be like some portion of the first few bits. So it goes from the start to the end, and the number basically tells you how many of those bits are in there.
Okay.
Does that kind of make sense? Sorry.
Yeah. I was wondering, like, for like especially like next gen firewalls, do they help like against anything else? I imagine like if it happens in Kabbalah or something, then there's like you can't just like figure they have a bunch of thousands of IP addresses. Something how do like this.
So
A lot of it, I'll start. I want you to cut off in a second. A lot of it comes down to how many resources you have access to. Now, it's very easy to DDoS a server that has limited X number of boxes and can only really handle X number of X bandwidth. Does that make sense? If you're Cloudflare, you don't have much to worry about because you've got next gen firewalls that are cloud hosted, right? And easy to deploy, at least at mass. So depending on scalability, that really determines whether or not you're able to do something like that. Suchit, which one's
So, beyond that, that is a harder part of it. But I guess your more advanced firewalls would be able to block out traffic. It would either have like a prove, you're a human type capture sort of thing. And, if you're blanket trying to DDoS, at least in the more simplistic DDoSes, they wouldn't go and be able to like click on every single one of them. The way that like a capture works is it looks at like the way that your mouse moves when you click on it to like that's basically how it tells you're not a robot, not you actually clicking on the box. So stuff like that, also like delays in terms of your requests can help with that, and that's some of the stuff that I've seen. But there are more protocols, obviously. There was
Yeah, one more up here.
You already answered it.
Okay, good. Good.
perfect.
One quick thing I want to point out, because I want to keep moving forward here, but why might that be a problem? All right. Basically, I'm saying that I'm going to allow traffic, if it originates here, to communicate outbound. There are going to be a lot of times when I don't want egress traffic to allow a destination that is outside of my private network, if it doesn't fall within that subnet. So when you're configuring things as a system administrator, I want to transfer that over, right? So devices that fall within that specific network can only talk to other devices that are also in that network. If, for example, it remains configured such that you've got any destination, so any IP that falls outside of this subnet, for example, you got a major vulnerability, a very obvious one, that you're allowing egress traffic to attacker boxes most of the time at an adversarial level, originate from IPs
This way,
that are outside.
Michael, because plenty of networks are going to require outbound internet access to run, so you set your updates from.
I would say a vulnerability is if you change the outbound to inbound. Let's look at changing your outbound to inbound. I think that might.
The only way that hackers can use this against the inside machines shell side.
Yes, exactly. Yeah.
Like if you specify the directions to be the destination, to be more conditional, then they might not be able to get a first shell.
Yes.
So the fire would block the outgoing.
Yeah.
Yeah, so it's vulnerable depending on what you think is going to be like normal and allowed, right? If you know that there are going to be specific devices on a network that shouldn't have egress, then you really want to review that. Otherwise, I think Ronan brought up a good point. There are times when egress is a essential like service, um, or originally it's like from an essential service that your devices need to have anyway. We're good to go.
So this is the Linux firewall. So there is a net filter base. So basically what IP tables do is they provide various functionalities to control network traffic. And like Michael said earlier, it works. So firewalls work in a top-down basis. So the rule defined in your first row is the first thing that's applied. Now, why this matters is, I don't know if any of you are familiar with like SQL or something like that. We're going through like a database. If you want to like run a command, you usually want to have like the thing that you use the most up top so you can run it the most and get it out of the way first. Oh, cut off.
Yeah. Sorry, it's back on.
So then NF tables are another tool. They're the successor to the IP tables utility with enhanced packet filtering and NAT capabilities. So there's firewall D. It has a predefined rule set. The rule set was, as we defined before, like outbound, inbound, specifying source and destination port, etc. And then it works a bit differently, but it comes with, pre-built network zone configurations. So what a network zone configuration is like, it's like a partitioning between like your inbound and outbound. So one of the most obvious examples, like a network configuration you might want to use, let's say Netflix, right? Recently I tried logging into Netflix, and unfortunately it said you are not on your home Wi-Fi network and you cannot log in. Bummer. What they used was a zone network configuration. The slimy executives were just like, if you are not in this geographical location, you're not on this network, you cannot access the servers from this account. Yes.
We use the VPN, but
Yeah, you probably can. Probably, yeah. You very likely. Huh?
just the top, they could collaborate and I take out the stuff.
They could also do that, yes. But I think Netflix is late, so I don't think they would. But we can try that out. But that is one example of a network zone configuration that I, recently ran into, unfortunately. You can also think of it like, let's say you're on a government website, and then you get a ping, a network access from Russia or China. You'd be like a little suspicious. So these are where network zone configurations and pre-configurations like that really comes to play in terms of blocking traffic. So then there's the uncomplicated firewall for Linux, the UFW. So first of all, you have to enable it, sudo UFW enable. Very basic commands. You can look up like different commands that basically have the same functionality as the slide before, just different interface through your command line. And then sudo UFW disable. You can reset your rules, and then you can block a specific port as an example. So sudo UFW deny 80. You're denying all traffic coming in and out of port 80. Cool.
That would work.
Yeah, so just for information, these like IP tables and stuff are not just firewall, are not just intended to filter traffic, although in most use cases that will be what they're used for. They in addition also supports some sort of traffic redirection and rewriting. So essentially, if you want to use IP tables to manually build like a router model or redirect traffic between different interfaces, well, that's basically what a router does, right? You can also do that. So they have more utility than you might expect.
IP tables is huge. You're gonna keep seeing that come around a lot.
And I was having this discussion actually. Netcat actually has some like insane capabilities. You can basically use it to port forward as well as like connect and stuff like that. The tool set is very diverse, and as we go further into your education, you'll learn more about like the overlaps between different tools.
The firewall daemon is really popular on Linux. Daemon is a background process. This is very popular depending on the Linux distro you're running. But remember that we talked a little earlier about zones and how pre-built zone configurations happen. When you enable the firewall daemon, depending on the Linux distro you're running, you can actually find the zone configuration files in this specific directory. Now, one thing I'll caution is important for sysadmins to keep in mind is that you're given a pre-built configuration and not a lot of things that you might install. It's a really good idea not to use what's been default and been built out like for you provided. And the reason why is because not always is it going to suit your needs, and assume that everybody who knows that you're running that also could make the assumption that you probably haven't edited that or changed it in any way and personalized it for you. So that's the first thing you would start doing when you enable the firewall daemon service or process. One big one that we're more concerned about because we think it's especially relevant, we do operate with pfSense on our cyber range. We're not going to show you a demo of pfSense through our cyber range. We're going to show you it on another cyber range. But pfSense is the GUI, and there are some command line equivalents for it too. It's open source. And so everything that we've been showing you as far as the images has been coming from snippets from pfSense. So I'm not sure is the can you guys see the image okay from the back?
My demo is actually using this later on, so
We'll see this even more. Okay. But like what pfSense really does that's awesome is it walks through configuration. And it allows you to make these decisions like pretty much just on the spot. What you're seeing in the image is a table full of local area network rules. Doesn't matter the actual specific network right now. The point is, when it says drag to change order, what you're seeing is the actual rules being laid out and written out for you. You can edit them at any time. When you drag them, you change their rule priority. Remember, top to bottom. That's why pfSense looks the way it does.
Cool.
Yep.
So, in the case, as somebody out there was mentioning earlier, in the case of more advanced attacks, firewalls don't always cut it.
Sorry, let me check something. Yeah. Did we get rid of that slide? Interesting. Okay. Well,
I'll post it later, but there are a bunch of advanced timeout scams. They're still very detectable.
Slide's still there, right?
No, I think it's hidden. Hold on, let me put it back up. You want to show it?
Yeah, I think. Sorry, guys. I said.
Okay. There you go. Yeah, that's fine.
All right. So Nmap has some like stealth capabilities. Obviously, there are ways to detect this, and if it's a public thing, don't use this on an actual target. This is just for your knowledge. But basically, what SS does is stealth mode, and then PM continues even when there's no reply, so it just keeps pinging, and that's just for time saving, basically. And then -F scans the 100 most used ports. So basically, if you just want like an overmap without basically putting out too many pings to a specific IP address. And what this does is the -D uses decoys, which are essentially alternate IPs. So if you look at Wireshark traffic, you usually see like a source and destination IP, right? Do you guys remember the Wireshark thing? Does anybody need a refresher on that? All right, cool. So there are source and destination IPs, and when you use the -D decoy, what happens is you can specify a random. So what Nmap will do is it'll pick two random IPs and it'll send the traffic through that. So how can this become problematic? Let's say you're looking at like rules on a firewall, and then you're a high traffic service provider, like let's say Netflix. You see a bunch of pings, but they're all from different IP addresses. In your mind, it seems less likely that this is just like an Nmap or like a ping attack on you. But if you have like a single IP address, this is more like noticeable, you could say. So the decoys work in a way that it distributes your messaging from like different IPs, but it's still your same like source. Now, the amount of decoys this uses does encrypt the number of messages you send, to be aware of this, but it also basically hides your traffic. And you basically don't use your actual IP, you use some random ones that Nmap generates from you, which
makes it harder to trace like Nmap and pinging back to you.
Just be clear, it won't actually hide your IP, it'll like hide it in the noise of the decoy.
Yeah, sorry.
Yeah.
Yeah.
Question?
How do you send a request that's not from your IP from your IP? 'Cause if you're accessing a network, if you're accessing accessing a route or whatever, you are physically sending the traffic from your device to the assignment IP. So then how do you send a equally packet that's not?
Yeah, I can answer it. Let's say I send you a mail, but I say I am Ronan. Right? You'll get the mail, but at the same time, if you were to reply to him, I will not receive the mail. This is the same thing. I can just claim I have this IP, but I will not get a response because it will get routed everywhere elsewhere. So essentially, this is just to make it appear such that your host is getting scanned by multiple IP, and only one IP you can only get response for. So it just generates a bunch of like essentially junk traffic. You can think of it like that.
So the router doesn't exactly verify. It's like the mailman doesn't verify your rules.
So, what you have to do for this is you need access to your router in order to do this. And what I'll say for that is routers by default have they do their own thing with network address translation, where they kind of like deal with this entire process for you. But if you're just a computer and you connect to like Illinois net and you try to do this, it will not work. At least I don't think it will work. But if you are directly plugged into the network, bypassing any routers, and you have like a public IP address, nothing inside 192 or any of that, but you have a public IP address, and you just send traffic out into the internet through something, you're able to disguise your source IP.
Yeah.
Correct me if I'm wrong.
You're absolutely right.
That is definitely
Yes.
So I'm curious, so I know like with DDoS, you typically need many, like you need many, like.
Many computers.
Otherwise they can just block you. So I'm curious, like, how do they block you other than your IP? Because if you can just lie about your IP, how do they block you?
So this is one of the things that I was talking about earlier with like firewalling. There are also, I guess, there's different methods. There's like a stalling method where you like stall requests, etc. There's also like the capture method. Beyond that, I think there are more advanced firewalling techniques, though I will admit I'm not that aware of them. If anybody would like to chime in, that's cool. But those are some of the biggest methods. In terms of like you have to verify that you're a human and that this is your request for it to go through. And somebody who's like automating thousands of messages won't be able to do that for all of them. So the firewall will block most of the DDoS. And also to make a note on this, DDoS attacks on like large servers, etc., need multiple traders because if you just ran like Nmap from your single computer and you made a bunch of decoys, your compute and like the rate you could send requests would not be enough to actually like overwhelm a server.
Also, if you think about it, ISPs themselves don't want junk traffic. So let's say I send out the request through Illinois net through some sort of like IP from the other side of the world that does not exist in Illinois net. It's the Illinois net internal firewall is probably going to see that anomaly and block. So I'd imagine ISPs would probably do something similar where if the traffic originated from one of their nodes and they know that the IP is not correct, they might silently drop it. So this like mitigates a little bit.
And go for it.
That's more to do with like network zones, etc. In terms of like a firewall, it's like block settings. There are more advanced techniques that we'll get into in a bit.
Yeah, what I was going to say is there are advanced firewall rules you can write. Again, I'm also not too familiar with these, but you can write rules to like analyze like, hey, am I being DDoSed? If so, I want to start like lowering my thresholds and blocking more IPs. And I want to start blocking wider ranges of IPs and so on. You can write rules like those. But also like I forgot the number, it's like 60-70% of the internet uses Cloudflare or something. So most businesses will normally just outsource DDoS protection to somebody else because it requires to be able to handle like even if you have firewall rules, you need some place to run those firewall rules. You need some server that runs those rules and prevents that traffic. Like Michael was alluding to earlier, you need a lot of servers in order to do this in the first place. And Cloudflare the reason Cloudflare got popular is because they decided, hey, we have a lot of servers, let's like offer DDoS protection as a service to businesses. So that will happen as well. But there's some aspect of this that you can do with your own like internal, say your company firewall or whatever you're doing, but many times it'll be outsourced to someone else.
Any other questions?
I mean, these firewall rules can get pretty long too, and they definitely need to be looked at from time to time. You can't just write a rule. Some rules are just going to stick, others need to be modified through time.
Cool. Yeah. What? All right, there we go. All right. How to detect advanced attacks. So firewalls don't always cut it. So you need like advanced intrusion detection systems. However, Ronin will probably be able to break through your intrusion detection system. So not completely foolproof, but it is better. And there are tools such as Combo Security, Onion, and Snort. I don't know if any of you have completed Tracer Fire last year, but basically, sorry, was that a question?
Yeah.
Yeah.
Wait, what's the difference between an IPS and a firewall? Which one is like no detected?
An intrusion detection system?
IPS is a really complicated term.
Yeah,
You have like a layered thing, right? Like normally, if you use the term IPS, like what is your intrusion prevention system? It's going to consist of a bunch of components these days. You have antivirus, endpoint detection and response, net flow analysis, deep packet inspection, and firewalling. And you could call all of those systems together as like one IPS, where you could like parse out. I don't think there's enough precision in terms of the terminology.
But basically, the reason that like intrusion detection systems, I guess, are like an additional layer on firewalls, are they will store the network traffic and then like advanced like one of the biggest things that people sell in terms of intrusion detection is that they will say we monitor like I was having this conversation. So let's say that you log on, you work for 9 to 5, you close it, and then you don't do anything else outside of that. Let's say your coworker wakes up at 3 a.m. starts grinding until like 6. So what the IDS will do is to look at the network patterns of when you log out of different coworkers, and it can look at like a time zone. So let's say you work from 9 to 5 hours today, and then suddenly they see network traffic from a different region at 4 a.m. And it's just like, what's happening here? So they can flag that as an anomaly. Intrusion detection systems are basically for anomalies like that. And let's say your coworker who's up at 3 a.m. If they catch something from him at like 4 a.m., they're gonna be like, okay, this is regular traffic. So you can get very specific in terms of like actual users, the time they've accessed it, but like the specific traffic they're surfing, and categorize their server based off of that to create rules for like specific anomalies. That's one of the biggest ways that intrusion detection systems are used in industry with my conversation.
Alternatively, if you want your firewall to automatically send a report to National Labor Relation Board, you could also do that because you should not have your employees working at 3 a.m. But anyways.
All right, we need to keep it moving. So let's talk more about containerization. We'll skip the scenario. Who's heard of Docker? Yeah, I've only ever worked with it once or twice. But the basic rundown is that the understanding of containers versus VMs, right? You've got a virtual machine, and it usually almost always has its emulation of actual physical and network hardware. Your containers are the lightweight option presented such that they only host applications. And they can host many different applications. But here's the cool thing about containers. They actually are designed to borrow from a host system. So they're providing a degree of separation between the actual interface that the container is and the host operating system itself. If we're questioning the ability to protect access and separate an adversary from a host operating system. This is one way to go about it. Docker is one of the most popular, things out there. So that's why we're going to talk about it here. So remember, running from a hardware level, but they borrow overhead. They're lightweight. There is some tips when it comes to Docker security. So their default capabilities, and they most likely work for a quick sandbox as well. There are reasons though that it is far from perfect.
Thanks, Dennis. These are all quoted from Docker's own security page. But Docker does have some like weird security issues. In the sense that it wasn't really designed as a security sandbox. That's the key part here. It was more designed to just like give you an isolated environment, but not really care about like too many of the intricacies of security. And so most of the stuff that you see with security for Docker containers are kind of just like built on top of it, just to like patch up a few holes here and there. So for example, this thing is if you have a Docker container and you have the permission to make a new Docker container from that Docker container, you can make a new Docker container, mount the entire like host operating system through that Docker container, and then just access it and do whatever you want. AKA read password hashes, read configurations, etc., etc.
How about ports?
What?
Ports. Docker ports. Okay, so there's a weird quirk of Docker where if you're not careful, it would automatically punch holes through your firewall to allow the service to be accessed from the outside. So by default, if you spin up a Docker that listens on, let's say, 00080, it will just, even if you have like IP tables or UFW configured or whatever, it will automatically add an exception without alerting you to make this service available to open internet. So if you're not prepared to do that and you accidentally did that, I'm just saying be careful, you know. That's also the thing Docker does.
To follow up on that, the reason why it's able to do that is because it requires root privileges. So Docker gets it. That's why it's able to overwrite.
And in fact, Docker without root is just kind of like an experiment they're trying out. It's called rootless mode. They're trying to get it to work, but like most Docker is just run as root. And so most of these exploits just kind of work. So with that said, I'm going to talk quickly about FireJail. FireJail is kind of like imagine Docker, but also not containers, and it's built for security. So the reason you use Docker for an application is you have an application, you don't really like trust it too much. Say you're given the application, or like you want to quickly patch it up or something. You put it in a Docker container. It is sandbox, but also there are a bunch of loopholes like we've talked about. FireJail is kind of like the security focused version of it. And it does stuff similar to Docker, but it uses something called profiles. So the simplest profile you can make is blacklist. You can say, I don't want the application to access something. So for example, in this case, let's say, and we kind of skipped the scenario, but let's say like /etc on Linux. Anyone know what /etc on Linux does? What does it store? Configs, exactly. So normally sometimes some applications will require like a folder inside /etc to store their configuration files. So in this case, you're saying, hey, you can I just don't want you accessing etc shadow, which in Linux is where password hashes are stored. But now, is anyone like think of an issue with this? Off the top of your head, just shout it out.
Symlink. Can you Symlink? That used to be a classic for meetings.
Well, I mean, you have to. I'll get to symlinks later,
Okay.
but
Could the application like change the FireJail profile?
no. You cannot, because the application is spawned within the FireJail profile. Kind of like it's inside a Docker container, but also not really. It uses something called Linux namespaces. If you want to look more into that.
Do you think like things that put up in the spawn of the Docker containers will have they have to be allocating this write a script and then run the script independently?
Okay, I'll get to all that later. But what I was looking for is you don't want to blacklist every single file individually, like that, because there are a lot of files you want to blacklist. So the solution is to whitelist, which is to say you can't access anything, but you can access the one folder that you need. So that's quite simple, and you can do more stuff with this. So quick intro on whitelist. It's going to basically like bind mount, similar to how Docker mounts directories, into a temporary file system, which is in your memory. And then since it's bind mounted, that means that any edits to either end just are copied to each other in real time. You can get more fancy with this. You can make it read-only, so that now the bind mount is read-only. You can't edit it. For example, you might not need to edit configuration files in the application, so it's a bit safer. It'll be mounted read-only. Now, let's say the application just absolutely needs to write, but you don't care about what it writes. you can use private, which is going to say, hey, I'm going to copy everything that's in there, but any changes you make just don't matter because it's all just going to be deleted as soon as the application ends. So different ways to control like what it can access. And then one other type of attack that you can do, let's say, okay, you've been very limited in all your directories, but you can still spawn a bunch of processes or allocate a bunch of memory or do all that stuff. These are your limits for that. They say, hey, you also just like can't like basically like denial of service the system as an application. Reason we're talking about containers with firewall is kind of these are all kind of just like locks to prevent the application from doing something that you don't want it to do if you don't fully trust it. This now other miscellaneous. This is where I answer a bunch of these questions that you guys had. Step one here, caps.drop. If your thing has to run as root, Linux splits all the permissions that root can do into things called capabilities. So for example, can you create a file that is an SUID file or so on? Like all of these individual things that a root user can do are split into capabilities. And this command just says, hey, even though you're a root user, you can't really do anything that root needs to do. These are all like not all of these will be found in a profile. You can just pick which ones you want, for example. So no new privs. You can't run SUID binaries, which are binaries that will automatically change you to the root user. Things like sudo. No groups. You run without any groups as like even if you're running as like a user with certain groups or as the root user, all your groups are kind of wiped when you run it. No root. The root user doesn't exist. As soon as like the application gets put into a sandbox, there is no root user in the sandbox. The user just doesn't exist. So it can't like use any sort of like other vulnerabilities that Ronan's going to come up with and try to like privesk into root because the root user won't exist inside there. X11 none prevents any like tampering with the display. So like you can't just like make a bunch of new windows in your screen if you wanted to. And these other stuff are all gonna like stop a bunch of other permissions. So no DVD, no sound are all like which devices you can access that are plugged into your computer, and so on. So that's FireJail in a very like 5-minute nutshell. And you have other options to this. FireJail is the one I'm most familiar with, but bubble wrap also exists. And you can see some of the like highlighted like options are kind of similar to what FireJail carries, where you can like bind read only, you can symlink stuff, you can like allow some permissions, deny other permissions, and so on. And now I will quickly answer Ronan's symlink question because I did not provide enough context to answer it in the previous slides. Bind mounts, I don't think you can symlink out of.
Okay, I was just asking, that used to be a classic trick because a lot of point detection tools didn't actually follow more than one or two direction, and you could use like cheap tricks like that. I think FireJail's more robust, but I just have no idea how it works that way.
If you're talking about like symlink race conditions,
what I was saying is, for example, if you had something that was like a bad action, you could create this blunt layer in direction away from it and bypass filters. That's because a lot of stuff I've seen is very naive. If it's like filtering at like the syscall level, I think you're gonna be fine. That was just something I'd seen before, like once or twice.
As a little bit of explanation, a possible attack that you could think of here, if you were going back over here to, hey, we're going to whitelist this directory. What if the application just creates a new file in this directory and then tries to symlink, which is symbolic linked? This file is not actually a file; it points to a different file, to, for example, /etc/shadow or some other system file. That's why this new temporary in-memory file system thing is important, because it's not just like changing the permissions of the application to access certain files. It's literally creating a new temporary file system to put the application in. So within that temporary file system, you can't really go outside of it, is the intention here. And that's why all this like abstraction is necessary, if that provides some context. Here.
All right, yeah, these are the next meetings. So next Tuesday we got Linux, next Thursday, forensic side of Linux. So we're going to bring Bryce back on. And then Tuesday after that, we'll talk more about Windows, depending on the timeline. You know, that could always change too. We should.
I'm gonna do the demo
Do a
real
quick
quick,
demo.
guys.
8 minutes left. So you guys are trying.
All right.
Yeah. So this is
If
for
you stop us after we're done with this.
so this is for reference what pfSense looks like under the hood. This is a completely borrowed from CS460 Security Lab. Very interesting class if you guys want to take it. goes over like networking fundamentals and stuff like that. So I'm running these in like VMs. Give me one sec. Cool. So we have a very contrived example over here where I'm just trying to ping. Yeah. So very contrived example where I'm trying to ping something. So let's say I'm pinging. Why isn't this working, guys? Anybody have any ideas based off of like what Michael actually said initially about like a firewall? Yes.
Say like he has played one. Like it has a
Maybe. What if it has no rules at all? Why would it block this sort of traffic? Does it do it automatically, maybe? So in this case, yes, it does. As we see, we tried to transmit 25 packets. There were 0 received. It was 100% packet loss. And now I conveniently disabled this rule. Now, what does this rule look like? If I toggle it, and then remember to apply changes on pfSense. This is like very important. If you don't apply changes, they don't change. So what is this for? What is the ICMP protocol? It is the Internet Controlled Messaging Protocol. So basically, when you ping a device, what you're actually looking for is some like verification that that service is up and running. So it falls under the ICMP umbrella. So by nature of like this initial configuration of pfSense, it'll block all sort of ICMP. But if I do this, where I say, okay, protocol IPv4 ICMP, I allow any, notice that keyword, and then
Guys, ignore the X's here. This version of pfSense is bugged. That is a bug. These rules actually apply. So just imagine that they're green check marks when he says enable, things like that.
got it. So this will allow all ICMP connections, and I have applied it. So now, if we go to ping, it'll start actually transmitting the bytes and receiving them. Again, very contrived example, but this goes to show you about some of the default settings of pfSense and what you have to look out for in a firewall configuration. Because let's say that you actually do want to ping a service to see if it's alive, you might have to enable this just to so that your actual like server functionality can get up and running. And yeah, that should be it.
Now, if you want to tinker with it, a really good idea is to flash it to. Actually, pfSense lets you, this is open source, right? You can download the ISO and you can just, throw that on a virtual machine to play around with that. Just try to go through and see what it allows you to do. That might be probably the best way to practice with it. And I will say that we use pfSense for our range, but we're not letting anybody go in and change anything that we do with that. You'll just have to work around our firewall. That's the whole point of why we've set up the range the way it is.
The reason is if you break it, we have to go up to the server room up there and like manually fix it, and it's like super annoying.
Right.
So that's why.
So don't try to attack the actual box and screw things up in that sense. So just keep in mind you are working around a firewall, and that is the one thing that pisses adversaries and red team off the most, because they have to find a lot of workarounds for that reason.
Unless you come prepared.
Unless you're ready to do it.
Again, if you have the resource, feel free to just build a home lab, right? Install some sort of virtualization software such as ESXi, Proxmox, and then you can partition in your network, set up certain firewalls to play around with it. Now, since I've been heavily involved in setting up purple team infra, if you have any questions in that regard, feel free to ask me, and I'll be happy to answer them.
So any questions from anybody, including Zoom? Are there any Zoom questions for us?
Do you have anybody on it?
We have 5 participants on
Oh,
Zoom.
that's really good.
Yeah.
Cool.
Anybody on Zoom have any questions?
I don't think we can hear them.
Oh, yeah, just remember down here, we talked about the, private networks that are being reserved on a LAN. That's why you see RFC and then reserved, your 192s, 10s, your 172s, right? Things that are registered typically in the United States, you're gonna see. So that's what that means. I know it's not intuitive, but it's listed there for you. And those are there by default, and I don't think you can remove those at all.
You can. It's a interface setting. It's not a like.
Why does it let you trash it right here?
No, look. If you click on the wheel, it's an interface setting.
Oh, yeah, no,
Yeah.
you go to the bottom, scroll to the bottom, right? Yeah, if you check that uncheck, or, if you uncheck it, it won't show up.
I mean, as I was saying, like essentially all of these fancy firewalls are just an abstraction of IP tables. Well, they might not use IP tables, but they're just, you can think of them as an abstraction of IP tables. So, if you want to play with the raw rules or whatever, feel free to do them.
Yeah.
Alright, any final questions?
DM us if you want more resources, we can help point you in the right direction, training wise and stuff like that.
Thank you guys so much for listening and coming to this meeting. Have a great rest of your day.
All right. Yeah. DM me if you guys want to come to Cyberforce, or want to hear more about that. So I can keep you in mind if she says yes to my second team. All right. It'd be great. I already got some messages from some of you, but I'm sure